What's up YouTube? It's Daniel Ajayi. Welcome to Robotic, a YouTube series documenting my technical projects and exploits. Today I'm going to be building a Dino robot. It's essentially a robot that automatically knows when to jump when playing the dinosaur game that comes on Google Chrome whenever the Wi-Fi goes out. This project was inspired by a version that I saw on Instagram. So yeah, let's hop straight into the video.
You're watching Robotically.
I'm low-key super hyped right now. I recently ordered a bunch of robot parts because I wanted to build so bad. And the parts came. I was gonna wait and open it for the first time in this video, but I couldn't wait and I opened it already. But anyways, I purchased from my site called Banggood. I'm not sponsored by Banggood, at least not yet. But I still recommend them, like for anyone looking to get into robots, because they're so cheap. It's ridiculous. Let me show you guys what I'm talking about.
Robotics is not a cheap hobby for a broke high school student, but I still got motors with matching wheels, servo motors, distance sensors, even more motors with matching wheels, Arduinos, PCB boards, wires for connecting 9-volt battery, PIR sensors for human detection, passive buzzers, rocker switches, L293Ds, which allow you to control motors with an Arduino, IR sensors, and caster wheels, all for a very low price. Even if you don't know what half of that stuff means, you can tell that's a great deal. Alright, now back to the project.
The photoresistor tells the system when an obstacle is around. This works because the screen is white, whereas the obstacles are black, which provides a really strong contrast that the photoresistors can detect. So when it detects a change in color, it sends a signal through the jumper wires to the Arduino, which then sends commands to the servo motor to press down on the spacebar, which causes the dinosaur to jump. Alright, so let's build this. The very first thing I'm going to do is I'm going to use shrink tubing to attach jumper wires to the photoresistors.
And so I proceeded to attempt to use shrink tubing to secure wires to the photoresistors. I tried this for a really long time before I realized that the leads on the photoresistor were simply way too thin to be securely held by shrink tubing. I was mostly just burning my hand a lot. After a bit of thought, I decided to use packaging tape to secure the leads of the photoresistor to the wires. Once I got everything taped together, I brought my cousin's laptop over so I could tape the photoresistor to the screen. I taped the photoresistor as far away from the dinosaur as I could because I figured that would give the servo maximum time to press the spacebar and make the dinosaur jump.
Now that I've taped the photoresistor in place, all I'm going to try and do is attach jumper wires to a solderless breadboard.
A solderless breadboard basically holds the wires in place. For the next step, I connected the Arduino to the breadboard. The Arduino is essentially the brain of the robot. It receives input from the photoresistor and gives commands to the servo.
Instead of getting really tired, so now I'm drinking some coffee so that I can stay awake and finish this robot because I want to finish it. Now I'm going to open up my servo.
Last of all, I had to connect the servo to the contraption. I connected it to the Arduino via the breadboard and taped it down to the laptop's keyboard.
I have the photoresistor set up on the laptop. I also have everything connected to the Arduino and everything connected to the breadboard. That means that it's time for programming.
The coding was pretty straightforward. Like any good programmer, I turned to Google to find solutions to everything that I didn't understand. I kept programming for a really long time until I got to a point where the dinosaur was jumping, but there was a pretty big problem.
So it's 2:51 now, and I'm really close to a functioning version. The major problem that I'm having right now is that Arduino is so weird. So after it tells the servo to press the spacebar once.
I'll just save you some time. I was attempting to explain what the problem is that was in the code, but my explanation is very unclear. That's because my brain turns to applesauce at 2:51 AM. But basically, Arduino Unos don't support multi-threading. Because the photoresistor is so far away from the dinosaur, every time it detects a cactus, it has to wait a couple seconds before jumping or it will jump too soon. To make it wait, I tell it to delay for a certain amount of milliseconds. The problem is that once the delay period from the first cactus is finished and the dinosaur jumps, it starts the delay period from the second cactus, even though the second cactus is now closer to the dinosaur than it was when it was first detected. So by the time the second delay period is complete and the dinosaur jumps, it's already too late. I struggled for a very long time to find a solution to this. I eventually found moderate success with an entirely different approach. Whenever cacti are detected, the Arduino can add some milliseconds to the time at that point and store the number in an array. Then it can repeatedly check the array to see if the current time is equal to the time that's stored in the array. If they're equal, then it can tell it to press the spacebar. While this strategy seemed flawless, I kept running into random problems that I simply could not understand. The servo would press down and not come back up for a long time, causing the dinosaur to jump repeatedly and eventually die. Sometimes it would simply not jump even though a cactus was right there. Sometimes it would jump too soon, other times too late. I was beyond confused. Okay y'all, so it works pretty decently, but I'm not content because what I want is for it to hit like 1k, 2k, like get really high scores here, and it keeps dying at like 355, and it's for some reasons that I can't understand. That's what programming is like. It makes you want to pull out your hair. I just don't freaking understand why I can't get it. I'm just gonna keep trying, and I hope that eventually I'll get it. If not, this was pretty decent too, so. And so I gave up. Psych, no, lol, I hate to quit. After a couple days of productive sleep, brainstorming, and preparation, I was ready to tackle the giant afresh. And by that, I mean I was ready to code in my basement for several hours on end. I came up with another idea that might work. I could delay the first dinosaur by a certain duration of time. For the second dinosaur, I could compute the time that passed since the first dinosaur had been detected and subtract that from the delay period for the second dinosaur. I tried that and I ran into a whole bunch of problems, and that didn't work either. After a long while, I finally came to realize that getting it to 1 or 2,000 with the approach that I'm using is impractical. The game speeds up, so the dinosaur would have to reduce its delay time with time so it would jump faster. The code loops so fast that the photoresistor detects a single cactus multiple times. I have to make it check less frequently, but each cactus has a different size. So some wide ones end up getting detected twice or thrice, whereas some skinny ones go unnoticed. As the game speeds up, the cactus starts to go by so fast that the photoresistor doesn't even detect them, and eventually, the pterodactyls come in. So the dinosaur would need to duck, which would mean connecting another servo to the down button on the keyboard. And then night mode comes in and the sky becomes black and the cacti turn white, and that throws off absolutely everything. When you account for all of these variables, it starts to get very, very complicated. If I wanted to improve this further, it would require a completely different approach, such as using image detection. I might do a part 2 of this project in the future, so if you have any suggestions, be sure to comment them down below. Thank you so much for watching. Like and subscribe if you want, and if you really want to support this channel, I do have a Patreon. I appreciate every last penny you guys donate. Whoa.